Great job. So I think it was well, you kind of like wait for you to on Zoom, you have to look into the camera.
12 people. 12 people. Remote. Oh, the numbers on the stuff. What a pleasure to be with you today. Thank you so much for sharing your lunchtime with the Boise River Enhancement Network. This is Riverside Talk 2.0. We are going live after COVID. It's taken a while to recover. It is so good to be here in person. It's the difference for me between listening to music at home and being at a concert and getting to dance. This is perfect. Today's a special day because we have an in-house guest presenting a topic that's of real interest to the Boise River Enhancement Network. Whether you are a natural resource professional, a community conservationist, or a volunteer, these are the kinds of talks that provide you insights about what's happening day to day in Boise when it comes to the Boise River. It's like Boise Dev, but even more focused. It's focused on the river. We like to think that we are able to do good in the ground because we have people like you helping us. You are our foot soldiers. Thank you for doing that. We appreciate your time. We appreciate your treasure. We appreciate the talents that you bring. We have at least 12 people who are visiting with us remotely. Welcome. This is the Boise River Enhancement Network 2.0 Riverside Chat. Colin Custer is our speaker for today. Colin, I first witnessed present several years ago at the Idaho Water Resources Conference, Water Quality Conference, and I was wowed. I was wowed by the topic, and I was wowed by his presentation. I had no idea that there would be something on planet Earth that included people going out and counting mussels. I'd like to know what it is that motivated him to find this job and to enjoy it as much as he does. But I'm glad that there are people like Colin Custer with us to be able to protect our health, protect our well-being, and protect that resource that we find so, so important. Colin Custer, please tell us everything you know about native mussels.
Well, like Rob said, thank you for that, Rob. I'm Colin Custer. I'm sure you guys all heard that. But yeah, here's our whole spiel on native mussels in the lower Boise River. I'm sure we'll have lots of time for questions afterwards. So I'll get right into it. A little introduction about me. My team is the sampling and monitoring team. My manager is Doreen McCoy. She's right here. So it's not just me. We have a big, fairly large team. There's 4 of us with Doreen. I've been in this position for about 5 years. I'm a water quality environmental technician. So I'm not just a mussel technician. Some of my job duties, yeah, we have a lot of job duties. We monitor the Boise River. And so that includes continuous temperature monitoring. We have 25 sites. I think it's closer to 27. I'm kind of losing track at this point. And so we do this. It's a chain with a little canister, and we have temperature loggers in there. So if you ever see those on the river, leave them alone. I find them a lot just torn out, and we don't get data when that happens. So please leave those alone. And then we do weekly sampling at Veterans Bridge, Glenwood Bridge, and Eagle Bridge. So that's our camper. You'll probably see it along the river. Nowadays, we've just got that sweet wrap job. But yeah, so we're out there every single Tuesday, rain, snow, or shine. We also do the geothermal sampling first. That's a big deal. Everyone hears about that. And we're kind of the ones that go out and monitor that stuff. We also do the ester simplot ponds. We're monitoring E. coli, cyanobacteria, and we have constant temperature loggers in there. And we're monitoring dissolved oxygen. So back in the day when they're having all the cyanide blooms, having all that stuff happen, we tried different things. And one of the things we tried to do was destratify all of that. So we've been in charge of doing that. We also do a lot of bioassessment work. So we do habitat studies, and that's in part with restoration projects. We do fish metrics, so we do lots of fish studies. We go out electrofishing. We do macroinvertebrate collections, and of course, freshwater mussel monitoring. So it's a pretty small part of our job, the freshwater mussel part, but it's probably my favorite, definitely my favorite. So for people that aren't familiar with the Boise River watershed, this is it in its entirety. It starts off with 3 forks. We have the North Fork, the Middle Fork, and the South Fork. And so those combine to become the Boise River in total. And we also have a number of dams, and you can see when they got put in. And so diversion was the first one, which is kind of weird. 1909, then Barber Dam right below that. And Barber Dam is probably the smallest dam, but it started in 1910. Then we went to Arrow Rock, Anderson Ranch, and last Lucky Peak. And so this is pretty much our area of concern. This is what we call the lower Boise River. So pretty much here's Lucky Peak, and then Lucky Peak downstream all the way to Parma, where the Boise River enters the Snake River, is kind of what we work on. And so it's a very complex system. We have 76 diversions and 16 returns just in this section. So the Boise River is pretty complex. And then my team in general, we pretty much stick from Lucky Peak down to Middleton. We do go further, as you'll see. But one of the things I think is interesting is these average flows before Lucky Peak. So we used to see flows of 13,000 every single spring. And then now we're hitting highs of 4,000. When we're hitting 4,000, that's flooding. So if you can imagine what 13,000 would look like nowadays. And I've seen USGS, or it's called USGGS back in the day. They monitored back in the 1890s with flows of 32,000 CFS. So that's so that just shows the impact that dams have had on our ecosystem. So a lot of people would ask, why would the city of Boise be interested in freshwater mussels? And the main reason for that is we have 2 water renewal facilities on the Boise River. We have the Lander Street Water Renewal Facility here next to Veterans Bridge, and we have the West Boise Water Renewal Facility. These 2 plants are responsible for treating over 30 million gallons a day of municipal waste. It is cleaned and then returned back to the Boise River. And so because we put this water back into the Boise River, we'd follow tons of permits, tons of regulations. But one of the ones we'd follow is the Clean Water Act, Section 304A. We have to protect the aquatic species and receiving waters. So we just need to make sure that our water we're putting in the Boise River isn't really having an impact on native species. And so ammonia is a main constituent of concern. You know, it's basically a human byproduct. So in 1999, EPA said, when you have salmonids in your river or you're receiving water, those are your most sensitive species to ammonia, and that's what you need to protect. But then in 2013, they revised that and said, no, it's not salmonids, it's freshwater mussels. And so what we basically need to do for our new permit cycle, so when they said this, we're basically in the middle of a permit cycle. And so before we renewed our permit, we needed to go out there and say, do we have freshwater mussels or not? Because that would change our ammonia criteria. And just for you guys to know, we don't really put out any ammonia at our plants. We're some of the cleanest, but it's something you have to know for permitting. And so we kind of looked, and there was no physical mussel specimens in the lower Boise River since the early 1970s. So no one even seen them. And it's all anecdotal. It's all people that lived here forever. Like, oh, I used to eat those. I used to go out in the 60s and I'd collect them. But like, no one had seen them. There's no stories of them since the 1970s, really. So we needed to go out and look. And so why would we want mussels? Why would you even be concerned beyond a permitting process? Well, there's lots of benefits of mussels. For one, they purify streams. One pearl shell mussel can filter up to 1 gallon per hour during the summer months. I mean, that's a lot. So if you have 100 mussels in a group, that's 100 gallons per hour. So, I mean, they're incredible animals. They also have filter byproducts, are nutrient rich. So they'll bring in their food through their inhalant valve, and then whatever they can't really process, whatever kind is mucky, icky, whatever's in the water column, they kind of bind it with mucus to squirt it out, and it just kind of falls in front of them. So for one, they're binding the stuff in the water column that we don't really want, sediment, maybe heavy metals, things like that. but then it forms these little packets on the ground, and then these macroinvertebrates, your bugs can come along and eat that stuff. It's super nutrient rich. It's good for bugs, and they're good indicator of water quality. Like I said, like if you have mussels, they're providing food essentially for your bugs. And you're not going to have a super polluted waterway to have them. They are sensitive to various things like ammonia, but they also need fish for the reproductive cycle. And we'll get into that. So what kind of mussels are native to Idaho and the Pacific Northwest? A lot of people don't know that we have native mussels. When they hear native mussels, they think of the worst case scenario, which are in your basin, but we do have quite a few native. So we have the Western pearl shell, also known as Margaritifera falcata. They can live up to 100 years old, be 100 years old. And there's also some studies that say they can be over 200 years old. Wow. So these are incredibly long-lived animals. Their sexual maturity isn't until 9 to 12 years old. So it takes a while for them to start reproducing. We have Western ridged. That one actually might be listed as endangered. Fish and Wildlife Service is going through the process of seeing if they'll be listed as endangered. A lot of species throughout the US of native freshwater mussels are considered endangered, just not out here. Out east, they'll have 60 species of freshwater mussels in one river, and 40 of those might be listed as endangered. Freshwater mussels are taking a huge hit right now, but these Western ridge, they live to be about 30 years old and sexual maturity in 7 years. California floater, or Anodonta californiensis, lifespan 20 years, sexual maturity about 5 years, and the Oregon floater, about the same. So this was just recently kind of a subset, these Oregon floaters from the California floater. Everyone just called them California floater back in the day. I mean, back in the day, I mean like less than 10 years ago. And so so I'm hoping one day we'll have an Idaho floater, maybe. But yeah, so these are our 4 native species out here. So when you talk to people out east, they're like, you guys don't know anything about freshwater mussels because we only have 4 and we have like 1,000. Like, that's the same. So this is that life cycle of our freshwater mussels. All of our native freshwater mussels follow this life cycle. So you'd have a male and a female, or sometimes the mussel can be hermaphroditic, but still, if they're hermaphroditic, one will have to put sperm out into the waterway, and then another mussel will have to bring that in, fertilize the eggs internally, and then they shoot out their embryos, which are called glaucidia, and they're basically little tiny microscopic clams. And then these microscopic clams, they just free flow through the water column, and they only exist like that for a couple of days, and they have to latch onto a fish's gills. And so once they latch onto the fish's gills, they become encysted in flesh, and that's how they get all the nutrients. They're essentially parasitic to these fish, and they get all their nutrients, their oxygen, everything through the fish. And one of the interesting things about this is that the fish can only be exposed once to glaucidia. Once they've been exposed once, they form antibodies. So if they get exposed again, their body will fight off the glaucidia and they can't exist. So it's very parasitic to them. It doesn't really affect their health, but they treat it like a illness, essentially, the fish. And so once they get on the gills, they'll survive there for a while, they'll get bigger, and then they fall off. And where they fall off, they'll burrow down and they'll stay buried for a couple of years while they mature and then come back out. And that's the furthest they'll ever go upstream. A mussel can't go upstream past where a fish drops it off. So some of these places where you see fish barriers is where you'll find your most mussels, because the fish aren't going past fish barriers and they're dropping off the fish. And so that's pretty much the life cycle of our native freshwater mussels. Very interesting. So now we'll go a little bit into invasive mussels very quickly. You've probably heard about these. We do not have these. It's only found once in Idaho. And from what I understand, they eradicated it. So the 2 types of invasive are quagga and zebra mussels. Here's kind of what they look like. They have a lifespan of about 5 years. Sexual maturity, they can start reproducing in some cases before they're even 1 year old. One mussel can produce 82 to about 3,000 babies per day. And so they don't need fish hooks. We'll see. They don't need, so every single one that they're spitting out into the water column has the potential to settle and become an adult mussel. And so that's one of the big problems with them. Where with our native mussels, they have to have fish hooks, they have to have the right substrate, they have to have everything, where these invasive, they don't need any of that. And so they first entered the United States via ship ballasts that had come into the Great Lakes. They came from the Ukraine region. And so it was like the perfect circumstances. They're having a rainy time. These boats were out in the sea. They fill up their ballast while these quagga mussel had been flushed out into the bay, fill their ballast, and back, this was in the 80s, and these ships came into the Great Lakes and then released their ballast into the Great Lakes, filled with the quagga, filled with the zebra, and that's how we got these mussels to this day. Nowadays, they have a law where you have to dump your ballast something like 100 miles offshore of any country, so you're not introducing species to different countries. So that's directly where that law came from. The current use to distribution of these invasive mussels are the entire Great Lakes drainages, Mississippi drainage, Texas, Colorado, Utah, Nevada, and California. And so once they're somewhere, they pretty much don't leave. The Snake River eradication attempt was the first eradication attempt in the entire United States. So this is the life cycle of quagga. So they just need a male and female, they only need one or two. And so they'll put them out, and then they just become eggs, and they grow super fast. And then they use these byssal threads, which are just super sticky threads that can stick to anything, literally anything. And that's why they're so bad. They don't need anything, any fish to reproduce. And then they just colonize whatever they can hold on to. So here's a picture from Lake Mead. So this is just standard plastic piping. And so we have a new pipe, no quagga. 2 months, you can start to see some quagga. 4 months, getting pretty covered. And then 6 months, water probably won't be able to pass through that pipe. They don't really outcompete each other. If there's space, a quagga mussel will take it over. So here's a motor from Lake Mead. Wow. Here's a shopping cart from Lake Mead. And here's a native mussel out there in Colorado. I think it's Colorado. So that's one of the things, is they outcompete everything else. They can actually eat so much stuff in the water column that fish can start to die off too. So you'll talk to people that live down the Great Lakes, and they'll have stories of the lake used to catch on fire out there because they're so polluted. And now it's actually clear in a lot of places because these quagga have filtered so much. But that's the thing, is they literally have drawn everything out of the water column, even the good things. So that's kind of why these things are so bad and why we don't want them. So that's the difference between a native mussel and invasive mussel. So some of our search and monitoring methods, sorry you guys can't see the topics, I'll just say everything that's up there, are eDNA. So that's environmental DNA. And the way we do that is with this backpack, and it's basically a glorified pump. And we put these filters on the end. We're doing everything in triplicate. So we have 3 filters that we put on the end. The water is sucked up and then it goes through the filters. We take off those packs and we send them, or we just give them to the USGS Pacific Northwest DNA Lab. We're super fortunate to have the DNA lab here in Boise, because there's only 2 environmental DNA labs in the entire country. And one's here in Boise and the other one's in Wisconsin.
USGS labs.
Yeah, USGS labs, so I mean, it's incredibly fortunate because I can just drive down the road. We have the experts to work with, and yeah, it's incredible. So right now, what we analyze for when we're doing this is Western pearl shell, Western ridged, and California floater. And like I was saying, the floaters, any floater will probably come up with that as a positive because their genetic material is probably so similar. So if we're getting California floater, it could be Oregon floater or California floater. We do visual surveys, so that's snorkel surveys where we go out and physically try and find them, or we use aqua viewers. So that's this person breaking their back right there, and it's pretty hard on your back when you're doing that all day. And we're doing flow measurements and multi-probe sondes. So with flow measurements, you can kind of see just kind of in hindsight what kind of flow these mussels are enjoying. We know that they're there. We can see like, oh, this is a higher flow area, we're finding this amount of mussels and this species of mussels. This is a low flow area, we're finding this mussel, and so on and so forth. And multi-probe sondes, so that's what this is. And so every single time I take this out, we're getting dissolved oxygen, pH, temperature, conductivity, total algae and turbidity, which is just another metric we can use for monitoring these animals. So work done so far. This is going to be a lot of words and a lot of stuff. So we've done a lot of work. So in 2017 was really when we first started need to look for them. So that's when we were applying for that new permit. So the team went out and did a physical survey with eDNA at 7 sites. Of 7 of those sites, 5 sites tested positive for Western pearl shell, and 3 sites positive for California floater. Picture of you, Ed. There's no physical specimens found though, so still we couldn't say for sure. And this eDNA technology is pretty new. Like, so I mean, back then there was a lot of people saying like, could we use it? Is it reliable? What can you say with it? It's come a long way just in the last 7 years or so. So then moving forward to 2019, we had that data. We needed to really say what we have. So we collected positive control samples, and what that involved was we went out to the Bruno River with Fish and Wildlife Services, where we knew they had Western ridge mussels and they had Western pearl shell, and they even had some California floater at the time. And we're able to get those eDNA samples and say, we know they're there. So if it's testing positive, we know the eDNA is working. So that's what we did. We also went up to the Salmon River near Crassel out by Yellow Pine and collected positive samples for pearl shell. Out there, there's thousands of pearl shell. It's pretty incredible. So that's what we did first in 2019. And then we did a physical survey with eDNA at 22 sites. So we jumped it up from 7 sites up to 22 sites. Of those 22 sites, 17 sites were positive for Western pearl shell, 19 sites were positive for California floater. And we found our first mussel on October 30th of that year. We weren't expecting to find anything. Like we're almost wholeheartely about ready to say there's no mussels. There's no mussels in the lower Boise River. So it was super exciting to find mussels. And then after that, we actually found mussels at 4 more sites after that. So in total, we found pearl shell at 5 sites. Moving on to 2021, we pit tagged 40 pearl shell mussels with Fish and Wildlife Services. So I actually have a mussel out there on that table out there where you can see the little pit tag. And so what we do is we use UV resin and we just put the little pit tags on there, we just glue them on, and we put them back in, and we can actually monitor, because these mussels will actually burrow in the winter time. So if you go out to these places where you have thousands of mussels in the summertime, you can come back there in the wintertime and you won't find a single mussel. And they can burrow up to 6 feet underground. So they can go far underground. And that's one of the reasons we don't find babies very much either, because the babies stay underneath the substrate. They only start emerging too in the summertime once they get big enough to have a hard enough shell to start surviving those conditions. So we pit tag these so we can kind of watch how they're moving, if they are going downstream, if they're putting themselves up and moving downstream, because they just have this little foot that they wedge themselves in substrate, and as soon as conditions aren't right for them, they just kind of push themselves up and they let the flow bring them down wherever they need to go until they hit a spot that they think is good for them. So that's kind of the idea with when we started pit tagging these mussels. And we can get length measurements. So we can pit tag these ones, know their length, and then come back in a year, come back in 5 years, and see how fast they're growing. And so there's a picture of that pit tag mussel. So you can see they're really small. They really don't affect the mussel at all. And then we also sent in 4 specimens for aging. So we kind of want to see like what are our age classes that we're seeing in the Boise River. Are we seeing only 80-year-old mussels that skip the entire bad part of what we have in the Boise River? If you talk to people that have lived here for a long time, they'll tell you in Garden City especially, there's lots of meat processing places and for cows, and what they would do is they would just throw everything they didn't want into the Boise River. So you'll hear stories, people say there's cow heads just floating in the Boise River, there's intestines and all that stuff. You can think if it's intestines, if it's the insides of the cow, what is that high in? It's high in ammonia. And so that's one of these things that they're super sensitive to. So that's one of the reasons we weren't really expecting to find mussels, because they're all killed off during these horrible times where it was okay just to dump whatever you want. I have a journal article somewhere saved from the Journal of Science where it says, it's from 1964, and it said to drain your car of oil, just dig a 6-inch hole underneath the car, open your valve and just drain it and just cover it back up. And so, I mean, if you're living in Garden City and you're doing that, you're only 6 feet above the water table. So anything that's going into the ground right there, Garden City, Harris Ranch, anywhere, that's going straight into the Boise River. And so we kind of wanted to see if we're seeing a variety of age classes or whatnot. And yeah, so that's why we sent them for aging. We did another physical survey with 21 sites. This one's a little more focused. Pearl shell again at 17 sites, the DNA, and we found specimens at 8 sites. We were getting better at finding the mussels. which was nice to see. California floater DNA detected at 9 sites. Again, no California floater. But one of the interesting things is we started seeing some Western Ridge DNA. Like I said, Western Ridge might be classified as endangered, so that's something we want to watch. And so we started a monthly monitoring program in 2021, and that's when we saw it. So we saw it at one site only, but we saw the DNA pop up 2 different times. So that was kind of exciting. So with that, we started a probability of detection study. So we're trying to really nail how useful is this eDNA? How far away are we detecting DNA from these mussels? If you have a mussel in one spot and nothing, it's barren for 200 yards, are you still detecting that DNA, or do you need to be right on top of these mussels? Is flow affecting it? Is pH affecting it? Is turbidity affecting it? So that's kind of why we did that. And we've been working with USGS, with Dave Piliad, working on that probability of detection study. We had a few results from that one. But at the time, we were very busy. We weren't really focusing on the mussels yet. So the data was a little iffy, but we had some data. So that's, again, kind of the stuff we were grabbing every single month when we go out there. And then, yeah, in 2022, we snorkeled 3.8 miles of Loggers Creek for mussel distribution. It was a lot. Loggers Creek in total is probably like 4.2 miles. So we probably missed like less than half a mile. And yeah, we found a lot of mussels, but it was good just to figure out you can see what kind of habitat they're in. You can see what sizes. We were just kind of getting in these reaches. We did 100-meter reaches where we're getting metrics in those. And we recaptured and remeasured specimen that year. In 2023, we collected fish for Glaucidia. So we went out and electrofished. And then that's what we were doing. We took them to the Ormond J. Smith Museum with Dr. Don Zarovin, and we're able to look at these fish under a microscope and then see if we could see the little tiny baby Glaucidia that are attached to those gills, those embryos of the mussel. And we think we found about 6 possible positives. We think we might have hit it a little early because we did it in, what was it, May or June of last year. And so we think we might have hit it a little early, but we still did see a few of them. But we're seeing, brown trout, rainbow trout, northern pike minnow, large scale sucker. And so we're thinking these animals are pretty opportunistic. You'll see some species out east that they'll only attach Glaucidia to a single species. So some of them will only attach to bass. Some of them will only attach to a pike minnow or something. But we're seeing possibly that these are more opportunistic here. We also worked with ACHD. They replaced Mallard Bridge over on Park Center Boulevard over there, kind of by that Barbacoa, by Chicago connection. So they're replacing a whole bridge right where we knew there was a big mussel population. So they actually contacted us and they're like, hey, we think that we might be disturbing your mussel beds. Would you guys like to get in there? We're like, oh yeah. So they're super proactive about it. It was awesome. And so we were able to go in there. And then we went 100 meters downstream and about 100 meters upstream, trying to get out every single mussel we could find. And we moved them up to very similar sites. And so with that, we relocated 134 mussels in about a 200-meter section, which is pretty incredible. We pit tagged 101 of those mussels. We kind of just ran out of pit tags. Eventually, 101 is a lot. And then we developed an extraction and relocation protocol. So other agencies can use this. And so with that, we're trying to be as scientific as possible, so we took all the water quality measurements from where we're taking them out and then trying to find as suitable, as similar place further upstream as where we took them out. So we can try and make sure that we're not going to put them in an inhospitable place when we're moving them and have the best results. We also continued monthly monitoring at 3 sites within Loggers Creek. So I did that for about 7 months. With Corrine and the rest of my team. And that was in a continued probability of detection study because, again, we had these relocation sites. We had places where we knew we had mussels. And so we're taking the same measurements. And then this time I was a lot more diligent about it. So hopefully we'll get a lot better results. All right, so now we're going to get into a little more data heavy side of it. So this is the Western pearl shell physical detection from 2017 because we only had the several sites. Sorry, this map's so big, but we went all the way up to Parma. So that's where you can see, so they did it. And so these M's denote that we took those samples in the main channel, and the green is more positive, and then the red is less positive or no detection. And so you can see we surveyed 7 sites, and we had the Margaretifera falcata, or the Western pearl shell. We found their DNA at 5 sites. So that's really what motivated the team to start searching harder. And so this is the same year for the California floater, and we found them at 3 sites. And so we kept going. And so this is 2019. And so we did 22 sites. And of those 22 sites for the Western pearl shell, we found DNA at 17 sites. And you can kind of see why we're doing more sites at this point. You can kind of start seeing where there's groupings of DNA, where then we can take that DNA findings and then figure out, hey, where do we really need a search? Because at this point, we still haven't found any mussels. And so if you're finding just tons of DNA in a localized area, that's probably a good spot to start looking for these mussels. And so we did some side channel. You can see there's Loggers Creek where it says the S's are side channels. There's a few other side channels, and you can see our water renewal facility is there. And that year we did find, that's the year we found our first mussels, and we had the 5 sites with them. Oops. And you can see that where we're finding the mussels are places where we're finding a lot of DNA at. And so that's kind of what we expected. But again, the technology was pretty new at that point. So we didn't really know what to expect. And so this is the California floater again, same year, 22 sites, 22 sites surveyed with 19 sites positive. Still no physical specimen. But in 2021, we decided to focus more on the Boise region and not so much out all the way to Parma. There's a lot more influence, a lot more agriculture. So it made more sense to kind of stick into our own backyard. And so this is that 2021 survey. And so we surveyed the 21 sites. We found the Western pearl shell DNA at 17 of those sites. And we found the specimens at 8 sites. One of the main things I'd like to show on this is we found no DNA at this site, but we did find physical specimen. And the reason for that is you can see there's an M on this purple triangle. But if we go back, whatever. Well, we did the DNA out of a side channel. That's what it was. And we found the mussels in the main channel. And so there's a weird little channel over there. So that's where that weird little bit of bloop in the data came from. But you can see it kind of makes sense. Like we have faster flowing water. And when we get closer to these dams, we're not really finding Margaretifera falcata, the Western pearl shell. And Western pearl shell in general, they need faster flowing water. They need kind of gravelly substrate. Where you find that as you get further down, the closer you get to reservoirs, it's more sandy, silty, and just not great habitat for Western pearl shell. I like to point out these are 2 monitoring sites that we did that year. So we did the Lander Street side channel and we did Loggers Creek. And the reason we chose those 2 sites is we were just finding lots of mussels there at that time. And so that's where I collected, that's where we did our probability detection study for that year. Here's the California floater. So out of the 21 sites, we're finding DNA at 15 of those sites. So we know they're there. We just haven't found any of them yet. And in 2023 was when we actually found, we didn't find them. Someone actually called us up from the Loggers Creek area. And they're like, we're finding lots of these shells along this pond that's kind of draining. And so I went out there and yeah, there's tons and tons of California floaters. So it was the first time this last year that we'd ever found California floaters. So it was exciting to me. And so this is Park Center. And we can see the Boise River. So MK Nature Center is right up there. And then if we go back, maybe one more. So that would be right here. And we can see we're getting California floater DNA. So this is the California floater. So this is right where that pond is actually. And you can see we have the most DNA literally right next to that pond. So the DNA, I think, is a good sign of where to find these animals. So this is a little bit of data that comes from that, just to visualize from that probability of detection study. So right now, this shows the detection of the DNA. So what they do with those 3 filters they send in, they actually split those each 3 more times. And so they're gonna have 9 wells. And then if you have all 9 wells test positive, you have 100% positivity, and so on and so forth. And so basically we have the dates down here, and we're doing the exact same methods, everything, but you can see there's variability in our detections. And then when we compare that at the same time with the flow regimen, you can see that it kind of lines up. So we're seeing the Lander Street side channel. This is the Western Pearl Shell. This is the California floater. When we see when the flow is really low, such as April, January, February, we're not really getting DNA. We're getting high flows, we're getting more DNA. And that probably coincides with temperature. Because when we are getting higher flows in the Boise River, that's when they're releasing more water, which is during the irrigation season, which is around the summertime. So I think in the Boise River, flows have more to do with temperature than just flows. So that's kind of what we're trying to do with this probability detection study, is trying to line up our metrics with how it's affecting the uptake of DNA. So in this since this project started, we've measured 168 individuals. We did 152 in Loggers Creek, and we've done 16 in the main channel. And these are those metrics from what we've found. And so you can see the majority of our population we found is in that 81 millimeter size range. And we found very few that are smaller than that. And I think that goes back to the young ones are more buried. So the bigger ones are easier to see, they're more exposed. And so I think that's definitely just a sampling, that just happens in sampling for these freshwater mussels, is how you're finding them and what age ranges you are finding them in. And so these are those 4 specimens that we sent in for aging. We had 89 millimeter, 77, 70 millimeter, 50. And so we sent that to a US Fish and Wildlife Service lab in Wisconsin. Jordan Richard analyzed, and these are the ages he came back to. These mussels, you can pretty much age like a tree. And so what they do is they take half the shell and they cut across. This is where all the growth comes from. It's called their umbo. And they cut across it with a very fine saw, about $10,000 saw. And then they're able to go under a microscope and they count every single ring just like a tree. And they're able to age the mussels. And so one of the things that's interesting about this, like I was saying, these Western Pearl Shell are incredibly long-lived. They can be 100 years old. So we're finding an 89 millimeter mussel that's 18 years old. That means they're growing super fast. And we actually talked to another mussel biologist out of Montana. And when we shared with him these potential growth rates, this is what he said. He said, I can't even fathom those Margaritifera growth rates in the Boise River. Our 12-year-old mussels were 35 millimeters and a 90 millimeter shell was 80 plus years old. So that means in their river, this size mussel would be over 80 years old, where ours from that aging was about 18 years old to 20 years. So, I mean, it kind of makes sense. Like in a lot of these places where you're finding Margaritifera falcata, where you're finding the Western Pearl Shell are super pristine rivers, like incredibly pristine rivers. And with a pristine river, you're not going to have a whole lot of nutrients in the water column. In the Boise River, we do have nutrients. And so it makes sense that these animals have more nutrients to uptake and they can grow faster. And our temperatures aren't as cold as these high alpine rivers and stream systems where you normally find Western Pearl Shell. So this is kind of just a justification to me of that our aging isn't totally off. And so if we had a 55, this is when we remeasured the 24 tag mussels. If we had a mussel that started out at 55 millimeters and we came back and measured it a year later, which we did, it grew close to 6 millimeters in 1 year. And that's what we were physically able to see. And we can see it kind of follows this line, which is what we'd expect. The older the mussel gets, the slower it is growing. And so to me, this justifies our growth rates and those ages. I'm hoping one day that instead of having to age mussels, we'll be able to get enough data that we can pick out a mussel, say it's a 65 millimeter mussel, and be like, it's this old, it's 20 years old, it's 30 years old, then we won't have to kill it and send it in for aging. So that's kind of the goal. And so we did 9 in Loggers Creek. We were able to remeasure in 15. And like I said, we did all those pit tag mussels last year. And so hopefully in the next coming years, we can go back out and recapture those 101 mussels and get 101 new data points. And so that'll be exciting to see that. And so where we're at with our next steps, we found the mussels, we know we want them, we know they're beneficial to the Boise River. We're finding them up above and below our water renewal facilities, which is a great sign. And we're finding more and more every day. And so one of the things I would like to do is I'd like to compare DNA of separate populations to determine the origins. Were these mussels always there and people just stopped looking for them and people didn't really care if they were, or were they brought in? Like I say, in Fish and Game brings in fish from different areas to stock into the Boise River, where they attached to those gills and fell off. So are they closer related to a salmon river population? Are they closer related to a Bruno River population? Or are these from our river system? I like to verify the mussel ages, so I'll go back to checking those tag mussels and just making sure those growth rates are accurate. Do more water quality habitat surveys, just really nailing down where we're finding these mussels, what they like, and just seeing what they're doing. I'd like to figure out kind of exactly what type of velocities, what kind of water flow these Western pearl shell enjoy. So we can better understand where to find them. Nutrient loading, just kind of understanding where we're finding them, how much nutrients are in the water. And then we've been working on a habitat suitability curve with HDR. And so what that is they take various specimens such as fish, and then they can put in every single age class. They'll put in juvenile, an adult of these trout, and they can say with all these metrics, they'll use LiDAR, they'll use depth, they'll use flow measurements, and they can say in this part of the river, this is a good place to rear juvenile trout. This is a good place for mature trout to hang out. And so we've been lining that up because we know that mussels only hang on to the juvenile fish. And so if we can find the areas that are higher in juvenile fish, we're good for juvenile fish, there's a higher likelihood that we're going to find mussels there. It also has lots more things you can do with it, but that's kind of my selfish plug for mussels. But so then we're going to continue tagging and measuring. We're going to try and really nail down the fish host. So we've really been working with Dr. Zarobin out there at the Orma J. Smith Museum. He's a great resource. He's one of the top fish taxonomists in the Pacific Northwest. And then really working with these new side channel projects to see if we can incorporate mussel habitat and try and create good habitat for mussels. Like I was saying, if you have a good habitat for mussels, you're creating good habitat for macroinvertebrates, you know the fish are there, and just an overall pretty healthy ecosystem. I would like to run previous eDNA samples so that lab, that USGS lab, still has all of our old samples and they can retest them anytime they want. So we're in the process of talking to them right now about retesting some of those old ones so we can get control negative, so we can say absolutely there is none there and the DNA is working, and then we can go back out in the future, hopefully starting this year, and then we can start checking and doing monthly monitoring for quagga and making sure we're not going to have any quagga in the Boise River. And then if we do get up, we're going to be on it and hopefully get the ball rolling as fast as possible. Oh, clicked on something. So yeah, there we go. So yeah, thanks for listening, guys. And then special thanks to obviously Doreen and everyone I've worked with for the last couple of years on this project. This is not a me project by any means. This is everyone. I'm just presenting. So yeah, thank you, guys.
We've probably gotten better with time. I have many questions, but I would imagine you do too.
You might have to go up there and repeat them.
Oh, okay.
Did any of you know that Mussels existed in the river?
Yeah.
No, only because we sit by you.
Yeah. So the floaters float?
No, they don't. That's the thing. I can't remember where the name came from. I asked that question years ago, and they're actually the most buried one. So I don't like, when we were finding them in the Bruno River, you had to like dig through sediment to like they stay, even the adults stay buried. So that's why I think we found them at that Heron Pond. So that water receded and they were trying to run to get it. So they dig themselves out and then push themselves down to get back into the water. So that's how they're able to be found. So yeah, floaters are probably the least floating. Bad name.
Shout your questions out so that our colleagues who are meeting with us remotely can hear you.
I want to say something about Colin real quick. I work with Colin on the water quality team. These mussels are not easy to find in the river. But Colin is unique. Finding them, it's amazing. You can go out there for half an hour and not find anything. Colin comes in. So
Colin
we
the,
kind of give Colin a nickname as the Mussel Whisperer.
Yeah, it's pretty, yeah, fish and wildlife and then fishing game now call me that. So they'll call me like, oh, this Mussel Whisperer. I'm like. Sure, yeah, Gabe?
Are there any other like mollusk or bivalve species that you're finding in the river as well, or is it just mussels?
So yeah, one of the major things, so the question was, I don't know if you guys heard, was what other mollusca are we finding? So there are snails, which I'm not a snail person, that's a fish and wildlife. But one of the things we find all the time are corvicula or the Asian clams. And I have one out there. And so the Asian clams, they were introduced in like the late 1800s, early 1900s as a food source. And they've kind of just gone everywhere, but they don't have those byssal threads. They don't latch onto things. And we've actually put things on our field forms for substrate. So you have to categorize like substrate. If it's a rocky substrate, it's a sandy substrate. We have a new category called quagga or the Asian clams, because they'll reach down in places, especially lower where there's more agricultural return. You'll lift up your hand and you'll have nothing but the corvicula in your hand. And so these things, they don't gum up anything. They probably help filter. I probably wouldn't eat them. I wouldn't eat any of these because especially the pearl shell, they live to be 100 years old. What was going on in the river 75 years ago, 50 years ago? What are you eating? And so, yeah, we have a water treatment, a phosphorus removal plant out near, it's called the phosphorus removal plant now. You guys know about that. But when you go out there to that drain, we can't call it the other name anymore. You'll go out there, if you go out to that stream, that's where they get big. They'll get about that big. And I actually have always wanted to eat one of those, but they look delicious. But yeah, so that's the main thing. We have a lot of, what are those? We have a lot of New Zealand mud snails.
There's a lot of pond snails.
Pond snails that just get a lot of invasive snails just from people's ponds that we see while we're doing this stuff. And that's why we see a lot of bass in the Boise River too, is when flows come up, people have bass in their ponds and stuff, they'll come into the Boise River, but those are warm water species. They don't really get too big in our section. But yeah, as you get further down on the lower Boise River towards Parma, it's an entirely different river. And so that's why we kind of started focusing more on our section, because it turns into a warm water river where we're technically a cold water river in our section.
Thank you.
Yeah, do you have so what is the contingency plan for if quagga mussels are found in the Boise River? Are we gonna have to just wipe out all of these that you've been studying?
That would go to the Department of Ag because they've done invasive. So we'd sound the horn and then they would take it over. But yeah, it would probably eradicate every single thing, because they're targeting mollusks. And so with that, what they did with that, the one they found in Snake River, essentially they found one living specimen on a rock. They put a net around it. And then as they did the treatment, they would go back to it and see how long it took for it to die. And so what these animals can do, so when the water's really turbid and things like that, with our native mussels, with quagga or whatever, they just close up. And they can stay like that. They essentially hold their breath. And these mussels, invasive or non-invasive, they can stay like that for up to like 72 hours, just clammed up like that. So that's what they did. And so they went back and forth, just checking and see how long it took to kill this invasive species. And I can tell you that the native mussels probably couldn't have handled that. So yeah, if they have to do treatment in these places, the native mussels are going to be gone too. But yeah, they have to do scorched earth, because yeah, like I was saying, we have so many any wastewater, stormwater pipes, they all go into the Boise River essentially. Those would be totally inundated with quagga. We won't be able to use those anymore. Veolia's intake, we've got to give out 1/3 of our drinking water from the river through Veolia, and all those intake pipes would be clogged. All the hydroelectric could get clogged. So we're talking about hundreds of millions of dollars a year for the state of Idaho. If these things settle in. And so we're trying to establish partnerships. The governor is trying to do more, and then Idaho Power could be a big partner in this. Bureau of Rec and Army Corps of Engineers, basically the hydroelectric dam runners, will be huge partners in trying to keep the quagga monitored.
We have a question online from
Right.
Julia. It says, have you found large mussel beds in the mainstream? If so, where are they located? Like near banks, middle of the river? And are there specific habitat features that correspond to mussel beds?
We actually haven't, so that's one of the main things is like when you go out to these other places, like you go out to the Bruno River and you go out to the Salmon River, you'll find hundreds, and in the case of the Salmon River, you'll find thousands of mussels. Just entirely huge. You'll look over on the side of the bank of the river and you'll just see black areas. You're like, oh, it's just black rocks. And as you get closer, it'll be all mussels. But in the Boise River, the most mussels I've ever found grouped together were 5. That's the largest naturally occurring bed. But then when we relocated those mussels out of Loggers Creek, or not out of Loggers Creek, when we moved them from one place in Loggers Creek up, we had 2 relocation sites because we didn't want to put them all in the same spot. So we essentially created artificial beds. So now there are 2, and there are, I wouldn't say it's left bank, right bank, center. It's more the thalwag. And so the area where the most flows for the pearl shell need flow. They need those nutrients. They need that kind of substrate. They need rocky, gravelly substrate. They don't really exist in superfine sediment, things like that. And you wouldn't find superfine sediment in fast flowing water. But then those California floater and Oregon floaters, you'll find them in the most stagnant water. So I wouldn't be surprised if you're finding, there are beds in these areas. And that's one of the hard things with the way we sample. I don't scuba, I'm not scuba certified. But if we could, I'm sure we could find beds of the California floater or maybe even the pearl shell in deeper areas of the Boise River. So that's kind of our limiting factor. But as far as I've seen, is the most I've ever seen naturally grouped together is 5. Is that, Corey, have you seen more than 5 grouped together? Yeah, so 5. We don't really have beds, but now we do. So we created some. And we go back to those relocation sites and look for death and see if they're dying, and these 2 relocation sites, I haven't found a single dead mussel yet. And we redid that relocation like 6 months ago. So we still haven't seen any death. And so I've worked with other freshwater mussel biologists over the years, and that's what they recommend. You'll find there's Emily Blevins with the Xerces Society, and she said that's one of the things, like they'll do relocation efforts and they'll come out there, they've spent days, weeks, months doing these relocation efforts. They'll go back out there a month or 2 later and every single one has died. And so it's a big deal that we've done this, and we've done it in a healthy enough manner that we're not seeing mass die-offs with our relocation efforts. But those are the only natural beds or unnatural beds that there are. Yeah.
Is there any relationship between these freshwater mussels and any of the anadromous, fish species? The sea.
Oh, the sea.
Yeah.
Anything that's juvenile in the area. So if you had, like in Boise River, we don't have any ocean going fish. But like in those other places, like in Oregon and Washington, I would, if they're juvenile in that area, they're potential fish hosts. So those Glaucidia, those embryos, they only stay on for a couple of months. And so, those fish take a long time to rear. And so, so those areas that you have huge populations of those migrating salmon in Oregon, there's tons of freshwater mussels out there. So that's one of the people we've been working with a lot. We've gone to several trainings out in Portland. And so I would, and a lot of people don't like the Western species aren't really well documented either of native mussels. Out east they are, because so many are endangered, and out east they're like, oh, this mussel is exactly from this fish, but out here we don't know if that happens yet. Like when we first started the study, we're like, that's probably how ours are. Pearl shell only will stick to a brown trout or a rainbow trout or a bass or something, but now we're finding more. And so we only have these 4 species in the entire Pacific Northwest and California, so I would imagine that they use those fish too.
Is there like a target of what you want to see when it comes to mussel counts? Is more better always, or is there like a sweet spot of what you want to see? How do we make data informed decisions based on what you're?
Right now, I don't have a good answer for that, but I would say more is better right now, because before 2019, we didn't think there was any mussels in the Boise River. And so right now, we're considering like 100 mussels a lot. And when you go out to these areas, like I say, there's no bed. So you're finding one mussel 5 feet up, one mussel 5 feet up. But when you go to the Salmon River, which is a more pristine river, you're finding those thousands. And that's world-class fishery. And so I would say, as just an uneducated guess, my personal opinion is that the more mussels you had, the better quality. They're not like the zebra, they're not like quagga. They're not gonna overeat, they're gonna naturally hit that middle ground. They're gonna naturally hit when there's not enough food, they're gonna stop growing. When there's not enough, so I'd say the more the better, as far as my opinion. But in the future, with our habitat suitability curves, maybe we can hit that metric where we can see where that line is if there's ever too much. But right now we're still in those. We're beginning to hit conservation at our point within the city of Boise, where right now it's more of a monitoring phase, I'd say. So we need to figure out where they're at and then what they're doing first before I think we can hit that.
We have space for one more question.
Better be a good one.
Are there any ways to propagate these to like nursery or to kind of like encourage their ability to?
Yeah.
Does that exist or is that something that?
Yeah, so one of the things I didn't touch on, and I apologize, is the tribal impact or the tribal relationship with these freshwater mussels. It's a little different in the Boise River just because we kicked them out a long time ago, the Shoshone-Bannock. But Nez Perce are actually doing incredible things up near Lewiston. They're actually trying to find ways to propagate out in Auburn University. They actually have huge propagation programs for their mussels. But again, it's super hard because you have to get in a latch on, you have to have this right flow. But yeah, I'd say the Nez Perce and then a few other of the tribes out in Washington, the Umatilla tribe. So there's a book out there on the relationship that some of the First Nation people have had with these mussels. They're actually a survival food for them. They weren't like something they'd really tend to eat. The one of the main differences with these mussels, since they live in cold water, they're way chewier, I've heard. And so I've talked to a few tribal members that have eaten them, and they're like, yeah, I ate them once and no desire to ever eat them again. But yeah, so the tribes, they're the ones doing incredible work. So they're the ones looking at propagation. They've had super incredible, just really taking the reins on a lot of this freshwater mussel projects. A lot of good data is coming from. But as far as us, we're not there. But there's Idaho has no regulations on freshwater mussels either. So Oregon, Washington, Montana, Wyoming, Utah, even they have regulations on freshwater mussels. We're the only state. So I actually cold called a bunch of different fish and game offices across the state. And I was like, what do you guys think about freshwater mussels? Can I kill as many as I want? And they're like, are you a scientist? I'm like, no. And they're like, we need a scientific collection permit. So they figured out, because I was asking about it as a scientist. So I called back and I was like, hey, I was out fishing on the Salmon River and I saw all these mussels. And I was like, I heard they're good bait. Can I just go kill them all and then use them as bait? And they're like, well, that's a weird thing. It probably won't work, but yeah, go for it. And I was like, how many mussels could I kill before you stopped me? And they're like, we just come down and check. And you had like 45 or 100 that you killed. We wouldn't stop you. It's not the coolest thing to do, but no regulations. So that was like I called, all the way from northern Idaho to southern Idaho. And I was out on the Salmon River and I was looking, I took some really good videos of those mussel beds down there, and the game warden came down. He's like, I need to see your fishing license. And I'm like, well, I'm not really fishing, but I'll show it to you. He's like, what are you doing? Freshwater mussels. That dude had lived there for 7 years and he'd never seen a freshwater mussel. The game warden by Yellow Pine, where there's hundreds of thousands of mussels, about tens of thousands of mussels. So I mean, these things a lot of people just don't know about them, even when they're right in their backyard. So that's where we're trying to get the word out. And hopefully this is informative for you guys. Thank you guys so much.
Oh, thank you so much. There are many other people, thank you as well. Some of them are here in this room. Marissa Keith, our coordinator, who keeps the trains running on time and does the logistics for each of these events. And Madeline Wyatt, who is the chair of our outreach committee. Not with us today is Vicki Osborne. And then there's a board of directors that I won't mention, but they're fabulous people to work with and always working in the public interest. Madeline, tell us, because this is the start of a cavalcade of presentations that you'll have opportunity to enjoy. Tell us what's up.
Thank you, Rob. So I'll shout for those on video, but we're looking to do a Riverside chat every other month this year. And so Colin and City of Boise, thank you for having us and hosting us and for kicking off or reinvigorating our Riverside chats. But we're looking to bring a great deal more awareness about the river and the good work that all of us do around it to the broader community, right? For certainly the lower Boise watershed. The next two that I have teed up are, who did I just talk to today, Bob? No.
Did you talk to Chris?
I talked to Chris today.
Great.
I forget what Chris does.
So Chris,
Sorry, this was like 2 hours ago.
yeah, things are happening as we
Very,
speak.
very quickly.
So.
Fly fishing, we're doing a fly fishing initiative for specifically geared to women or to people who are looking to learn more about fly fishing and introduction to fly fishing on the river. And so personally, I'm really excited about that because we have a great fly fishing community here and I want to be a and we've got a few more in the hopper, certainly tapping Fish and Game pretty heavily since they're so expert on the river as well. And bringing them to the forefront in the work that they're doing. So we've got a great deal of topics going on. If you're interested in what Brent is doing, we send out a newsletter once a month. It's an easy way to be informed on what we're doing. I'm looking to really bring a great deal of the good work that we do out to the broader community. So please do stay tuned. Thanks, Rob.
Wonderful. And the people that we have to thank are you. Thank you for your time, your talent, your treasure, your interest in the Boise River. I got to tell you, after having moved here from the East Coast many years ago, it's a wonder to me that we have this kind of resource. We are so fortunate. Go out and enjoy it. Have a great day. Thank you.
Thank you so much, Rob.
Thanks. Nice to see you.
Oh, that's great. Thank you.
That
was so fantastic, Colin. Great job.
Well done, sir.
Then we're having.
I don't know, you might, I can do it.
next we're making-
Yeah.
Thank you.